Hello friends, welcome to VLSI Techno. Today I start Cadence Virtuoso tutorial. Before starting tutorial, I create a directory name Cadence directory. So it is better to create a directory in root form. You can create anywhere, but it is preference to create a root. So I have already created Cadence directory. You can create any name like Cadence directory, VLSI tools or anything. So I have already created Cadence directory. In Cadence directory, following file as required to start Cadence Virtuoso tool. So these are the list. First one is a CHRC file. So if you know about creation and modification of CHRC file, you can watch my CHRC related video. Second one is a foundry file or GPTK file. So here is the 4 foundry file. First one is these two are Cadence GPTK file. First one is 19 nanometer, second one is 180 nanometer. So if you want to this file, so you can download from Cadence website or Cadence support, or these are the two this is ACL PDK and UMC 180 nanometer. So in this one, this is GPDK 19 nanometer Cadence file. So in there are two library, cds.lib, cdb, and this is open access. So we use here open access file, not this one. And similar manner here is also two file. One is open access, this one, and this one is a related file, log file maybe. So in this is the cds.lib, means Cadence library. So in this Cadence library we give the path of your created library or present library. So this is and third one is a .cds.lib. So I already told about this cds.lib. So this is the cds.lib Cadence library. In by default they are already given this one. Otherwise no, if this file are not present, base library, AV tech library, PLL lib library, passive lib library, mainly two libraries should be present: analog lib and basic. In analog lib it is required for supply and basic for pin and no connection. So these two should be required. So if you talking about what is the location of this one, so it directly go on take from IC tools. So when you open CHRC file, this is CHRC demo file actually. So here it will automatically take this one. So if you are comparing these two files, so it directly go to CDS in. So it means it directly equivalent to this one, equivalent to home, this location. So if you want to know this where is the analog lib, so you can firstly go to this location, firstly. So I show you where is the file. Firstly go to home, IC6.1, this one, okay, and here. So directly go here and now move to tools DFI etc, tools DFI etc, okay, and cds.lib artist and analog lib. So this is cds.lib artist and this is analog lib. this library, so automatically it will take consider this library for supply. So if you open this one, there are supplies available: vSource, VDC, this one VDC, VDD, many file, ground file. So these are mainly supply pin are taken from analog lib, and basic will use for pin. If a pin is used, then we take basic library. Actually by default basic library is taken by Schematic. This will I will tell about in middle of this video about pin creation, pin location, pin taken, pin direction, and many things. So this is cds.lib cadence library. So and fourth one file is cds.int. Actually this is a optional file if you are using third-party tools as a verification tool, then cds.int file is required, otherwise no need of this file. So now copy this all file. I copy here. Actually already file is present here, so okay, skip this. Okay, so file is here. So this file, so firstly I give the location of file, technology file. So in cds.lib I tell about how to give the technology file or writing technology file script here. So write define and firstly I given UMC file. So this is UMC file. Control L to give the location, to get the location. So we press Control L to get the location, and now paste here and keep this last line as a name, define library name. So define library name is UMC underscore 18 underscore CMOS, and this is location of this library. And if you're taking another technology file, this is SCL. So we go to get SCL PDK file. So this is SCL PDK file. We go to open access. Actually two files are present, DFF and open access. So we take here open access, otherwise it will not appear at the time of library technology file selection. So we have take open access file. So get the location of file by pressing Ctrl L, and now give the another file location. So type this script, paste location and copy last line. You can give any name, but it is better to take same name by default. So this is the UMC library name, ts018 underscore SCL underscore prime, and these are location. This is location of this file. Okay, now if you want to add this file GPTK 90 or GPTK 180, so we directly take here this file location. So this is location is, so for location just press Ctrl L and get location. So we define new file So actually here am I including this file. So we use command soft include or include, any you can use. This is equivalent to a link and soft link, hard link or soft link. If you are using soft include, it's equivalent to soft link, and if you are using only include, then it will equivalent to hard link. So now location is come. So now directly what is this is and name of the file. So name of the file is cds.lib is this one. So copy the name of this file, paste here. So it automatically take this file. If you want to take another file, if you want to add 90 nanometer, you can similar manner. If you want to know the location, you can use this command also, or control L. If you want to use the command, just press pwd in a small note capital. So it will show the location of current working directory. So this is the location of file. Just copy it and include again. Soft include and location and the name of the file. So this is the name. So it is clear that you have to take only open access library, otherwise it will show error. So otherwise it will not take a library. Okay, when open this file, their definition already defined. Here is also defined and basic analog. So we can make one enable and another two disable. So I make this disable by using hash command before define. Save it, and similar manner here. This is 180 nanometers, and in similar manner we add in, we change in here. Otherwise it will sometime it will create a error due to the defined to base and analog lib. So now cds.lib file is over. Now starting Cadence Virtuoso. Okay, so right click and open terminal and type command chs and sourcing the chrc file. So the type command source chsrc and enter. You can put any name here, chrc, if you want to use chrc1, chrc2 or cadence underscore chrc, you can make any name. So I will take here by default chrc, so it chrc, and now I start Virtuoso. So we type the Virtuoso command. Firstly we check Virtuoso install or not, so use command which Virtuoso. So it will show the location of Virtuoso file. So Virtuoso file is present in here. Okay, if you want to use which aspect ray, so it will show the location of aspect ray file. So this is aspect ray location of aspect ray file. So this is okay. Now using if you want to know the which version of Virtuoso are used, so we use this command. So this will show the version of Virtuoso. This one Virtuoso is used. Okay, so starting Virtuoso, just writing the command. So or you can use any, if you are using 64-bit, then you can use this command. You can use any command. So this is open, Virtuoso is open. Now firstly we create library. So creation of library, you can create a many way, so I will tell about one way. So this firstly go to library or create, or you can using this one also. Firstly go to tools and open library manager. So this is a library manager. Here is the included file in cds.lib. So this is in VMC technology file. This is an 80 nanometer cadence GPTK file, technology file. This is cadence 90 nanometer GPTK file, and this is SCL file. Okay, so if you create any library, so just go to here file and create new. So firstly we create any file, so just type here demo or tutorial first. Tutorial 1. Okay, and press OK. So technology file will taken. So we take here technology file, this one. Okay, now we have to require technology file. Which technology file we want to use to create schematic or design schematic circuit. So I click on attach existing library file. Actually I already attach library different technology library file like UMC 180, SCL, GPTK 90, GPTK 180. So click OK, and here is the present technology file. This is a SCL, GPTK 180, GPTK 90, UMC. So you can select any one. So if you want to use GPTK 90, you click here, so it will take GPTK 90. If you are use this one SCL, so you can take here. So I am using here SCL, so click here OK. Now here we will look, this demo file will be tutorial first will be created. Here the tutorial file is created here, this one tutorial 1. Now we create cell view. So cell view, for go to this one and click here cell view. So a new window will come, and here is the library. So you can choose library, any library. So I make the library here tutorial, so tutorial will come and make the name what you want to create. So I am creating here inverter or designing inverter, so we make the cell name inverter. Here is the type, which type you are using. Here I am creating schematic, so schematic is click here. If you are using if you want to create layout, so click layout here. If you want to create HSpice type, HSpice view, so click here HSpice. So different type is present here, so it is your wish. If you want to write very low code, then you click here very low and many. So actually here I am using making schematic, so now we select type schematic, press OK. So a schematic window will be appear. So this is the schematic window. Okay, one other important thing I want to show you, I may create a tutorial lib, so automatically in cds.lib a tutorial file is created here. It will define the name. This is tutorial name, and this is the location of my tutorial first. Okay, One other important thing I want to tell you, actually many shortcuts are used in this Cadence Virtuoso. So how to know which mm, keyword is used for which tools or which property? So go to firstly bind key. In bind key they will show the shortcut here. So this is the key and their key, this is the hash key, will show this one as per. Here we press P, so schematic create pin. So when press P, automatically create pin. When we press W, it will take create wires. So schematic create wire by pressing W, and pressing P will create as a pin. So this is shortcut. You, if you want to change, you can change here, but it will take some difficulty if any new user will use this tool and they don't know the shortcut. So it is better to take keep in by default at it is. And now starting this one. So firstly I create inverter. So for inverter we have to require instance or component. So for the instance or component we have to go to firstly create here instance, or just press I, or it will come here add instance, or go here. So this three way you can create. So go, and then after you go to browse and select technology file. Actually I am here using ACL, so click here ACL file and select PMOS or NMOS. So firstly I will required select PMOS. This is PMOS, click on symbol. Okay, so firstly we create select on library, cell, then symbol. Okay, so after here we show the gate width, gate length. So we select here gate width 1. So it will take 1 micrometer. Actually by default as a unit of this one is micro. This is a ACL property, ACL file property, so there is no need to mention micrometer, it automatically take micrometer. Okay, and for another foundry file we have to mention micrometer, nanometer. So this is ACL file, so there is no need to mention units in this technology file. So already it will take by default take micrometers. If okay, if you want to create a width as 2 and multiplier 1, so it will 1. If you are using 2 multipliers and this is 1, it will take our total width should be 2. It means if you are using 4, so total width will be 4, and if you get with 2, the total width will be 8. So here is a multiplier, this is the first, so it will generally it will multiply to these two multipliers and get, so total width will be 8 here. So by default I take here 1. Okay, it will come here. Okay, another thing is here, so if you want to move this one or flip or this one, so just if you want to flip, just click here, it will flip. Okay, this is flip vertically. If you want to flip horizontal, click here and click here, so it will click horizontal. So I keep it by default. Okay, if you want to drag, just click here and move there where you want to move this, so just drag and move the mouse. Okay, now again create, we have required NMOS, so go to NMOS here. So already I selected library one SCL and we select cell NMOS. So this is NMOS, the symbol already created here, and make one other 1. You can change here by if you want to take 2 bits, just change 2 multipliers, 3 multipliers. Actually they have some limit also, we cannot put more than 1000 or 100 here, it will not take 100 micrometer width. So for that we have used, that time you can use this multiplier. For example, if you are using here, so it will show say error here is show the error, its width should not be 100, greater than 100. So if you want to create this, and this one 1000, so just click here, so automatically 1000 will be created here. Okay, this is width is 1000, total width is 1000. Okay, so this is method to create a large width by using multiplier. So here is also rotation, flip, side by side, up and down side, rotation right and left, any you can choose here also. Now selecting, okay, now move this, flip firstly. If you want to flip, just click, go to here and select horizontal flip, so automatically it flip here. Press escape if any property selected, just select wires, and want to exit this, just press escape, so it will exit. So now now go to for wiring. Here is a wrong wire created, so if you want to delete, just firstly escape this, so this will free from wiring. Now click the wires and press delete, so automatically delete it, or otherwise firstly we click delete, a window, a mouse like cross will appears, and click which component you want to delete. So here you want to delete this one, and moving the cursor, mouse scroll ball forward and backward, it will zoom and zoom out. So moving motion of a scroll bar, it will show zoom in and zoom out. Okay, now completing the wiring. This is bulk. Okay, now wiring is completed. So first if you want to create wiring, just firstly click any point, and then where you want to stop the wiring, just double click here or press escape, press enter, it will stop that point. Okay, now create pin, so click on pin or press P, anything P, automatically came pin, or you can go here, create and click here. So in 3D way you can choose the pin or create pin. So here is the add pin option, so I want to add an input in VDD, VSS, you select any VSS or ground, VDD. Okay, these are input pins, so input will come here. Okay, if you want press F, so it will fit here, so automatically fit the window. If you want to small, just scroll down, scroll forward and backward, it zoom in and zoom out will come perform. Now if you want to rotate this, just press R, so it will auto rotate the pin. Okay, I am pressing here R, so it will rotate. So we want to over here, now we will rotate this one in this direction, so this will come here. Now make this one, now finally is required output pin, so go and type out. Okay, output pin will come here. Now after this we have to check and save. So this is schematic is completed. Now here we give the pin and schematic. So if you want to labeling this pin, so you can also use this one, just like want to label this in, so we can click and here, so it will in will come. If you want to labeling this as VDD, just name the VDD. If you want to change here the style, you can change the style also here. If you want to change the font, it will change here by using this. And now okay, that's VDD. So this is labeling of wiring wire here, and now check and save here, so it will okay. So after the checking, it will show here schematic check complete with no error. Okay, now move to create symbol. For creating symbol, we go to firstly create, then go to cell view, and from cell view, okay, here is the show the two views symbol. and this is type schematic symbol. There are many similar at a previous type where is showing type. Here we select schematic symbol, so it will create symbol. So you can make name any different. If you want to name inverter 1, 2, so it will name should be inverter 1. So I am by default I will take here inverter. Okay, here is the showing the pin specification, in which direction we want to show the pin. So in left I want to show in. For out I change here as out, VDD as out top side, and VSS as ground. In bottom side, so I put in bottom as bottom pin, and okay, and now click OK. So creation of a symbol appear. So if you want to design symbol in different manner, so you can change here. So you firstly change the instance name. So instance name you put here. So if you want to put inverter, so in B come here. So if you want to check the style, you can change here. Okay, if you want to delete this, delete. If you want to delete this, so I am creating a symbol of inverter. Okay, now if you want to move this, just click and drag here, click on it and drag here, so it will move in direction we want to move. Just click here and drag. Okay, now creating symbol of inverter. So firstly we click on line, so this is line, and making the symbol. You can make any type of symbol, but it is your wish. So firstly click here and move here, then click here, then click here and double click here. So after double clicking it will stop here, or press enter. And now we have required circle. If you are here, this is circle, and this is ellipse, and this is for arc. So here is a for the inverter symbol we have required circle here. So firstly click here and move the mouse, move the mouse in any direction, circle will appear. So this is created. And now if you want to move this, just select here like that and move any direction. Okay, there is no need to it should be connected here. You can make symbol in any way, not necessary to make symbol like that. If you want to make the inverter symbol as a square, you can create a square or rectangle as you wish. So symbol design will not affect on your schematic. So this is symbol is created. Now we move to create a test bench. So now starting test bench creation. So symbol will come here. Okay, now close it, or if you want to open, so just go here, create a new here in tutorial same library file, and test, make the name test. So new tab will open here. So new tab test will come here. Now if you want to close this, just click here, it will close. Okay, so this is now test window. Okay, now move to go to instance and create here. Firstly go to tutorial. Actually we have already designed symbol, so here we click here to library, inverter and symbol. Actually what I do here, for example if you are using any NMOS PMOS, we click here and use symbol. So in same manner already I created a symbol of inverter, so I will take symbol of inverter here and click here. So automatic come here. Okay, now we give the input and output pin. Actually symbol is not if you have a small circuit or a complete circuit, there is no need to create symbol. If you want to this circuit as a sub circuit of any big circuit, just like for we are creating oscillator, ring oscillator, then for ring oscillator we use inverter. So this symbol will use at the time of creation of ring oscillator. So if we are using just one circuit, there is no need to big circuit, so we keep as it is, no need to create symbol. Only symbol is helpful when you when this circuit is a sub part of any large circuit. It's meant if this circuit is a sub circuit of any circuit, then you have to require create symbol, otherwise no need of creation of symbol. Okay, so this symbol is created. Now give the pin, so attach the pin VDD, ground, in. So this is input pin, so click here direction, so direction should be input, so this is input. So first is VDD, second is ground, third one is input. Okay, now create the wire, click on wire and complete the wiring. And this is output, so we type output. You can make any name, output or V out, anything. Okay, and complete the wiring. Okay, so this is the test bench creation of inverter. So I am stopping this tutorial here, and I will continue this tutorial test bench, continue from test bench in the second tutorial of actually second part of this tutorial. I will tell about the simulation of this test bench, and take also tell about stimuli and model library files and different analysis. So thank you for watching my video. If any query related to this tutorial or any video, any of my video, so just comment on my video, I will reply it. And till you doesn't subscribe my channel, so now subscribe my channel. Okay, thank you for watching my video.